Within our missions, the engineering portion of the STEM education is often covered with the design of the space shuttle, the O-rings which led to the Challenger disaster itself, as well as a lot of the different parts of the space shuttle and how they function, the rocket engines, the solid rocket boosters, the liquid rocket tank. All of these elements of the design are always emphasized within the mission in order to give the students a better idea of the design aspects and the engineering that has to go into the projects. One of the areas that the students often really light up to is using the robotic arms within the remote and ISO stations. Most of the time, the engineering portion of this, the students love working with the robots, and it many times intrigues them on exactly how the robots, as well as the isolation chambers over here with the glove boxes, and they can really appreciate the design that goes into the engineering portion of all the different stations. Even if they don't think about it a great deal, when they're building the probe and they have to accept the instructions from the mission control while they're building the probe, it gives them a great appreciation for how things have to be put together in order to work properly. In conjunction with the missions, many of our schools also elect to take part in the Great Rocket Design Challenge. And in the Great Rocket Design Challenge, we definitely emphasize a great deal of engineering. The students have to make a lot of decisions on designing and building rockets and then using compressed air in order to fire them to see who can have the most accurate rockets, who can design the rocket that will withstand the pressures that are created, and of course the accuracy of how they have to fire them with the angles, the pressures, and all those decisions that the students have to make.